Here we want to know how to solve a quadratic questions using this information. See, from the question we are given a table that we should copy and complete it with some variables. So we are having the x variables as well as the y variables. So one thing you have to understand here is that in graphing you need two things. You need these two guys. Is that okay? So you need two things here to draw almost all the graphs. But in this case, the best way to understand that is that assuming this is an assumption, assuming the x here is the amount that we are having. Let's say you want to buy this marker here at the bookshop, right? So this is the x here is the amount that we are having, and then the y here will be the product that you take home at the end. But this whole thing here is the procedure or the machine or something that will convert your amount or something that you are going to use to exchange the product here, right? So what I mean by that here, we are having the values from the table. Then what we are giving, you are giving, let's say x to be minus 5 here. So assuming this is what you are having, right? This is your price here. So this is your, or maybe let's say this is your amount. Is that okay? This is your amount here. So what are you taking home with this? So minus 5 here. Now with the help of this relation here, meaning that the relation between the product and the price is what 3 minus 2x minus x squared. So this is what you're having, meaning that anytime you come with a certain price, you must take certain thing home, right? So how do you do that? So when you came with minus 5 here, we take this minus 5 here and plug it inside our machine to determine whatever you must give you at the end, right? So how do you do that here? Now suppose you came with minus 5, so what are you taking home? So let's plug this minus 5 into our machine to determine whatever you must give you at the end of the day. So here meaning that you have a minus 5, so meaning you're having 3 minus 2, whatever you see the x, what you brought is what minus 5 here. So let's place that minus 5 here, right? Minus, remember this is x, meaning the x here is what you brought into bracket minus 5 here, all square, right? So this is how simple you have to solve this type of problem here. So here will be 3, this time this one will be in positive 10, right? This minus, so this one square will be what 25. So when you solve this, and this should be what 13 minus 25 here, we are going to get minus 12, right? You are going, so this is what you are taking home. So you came with what minus 5, and then you are taking home with what minus 12. So assuming this is just a product, right, for understanding purpose here. So you are working in pairs, so you came with what minus 5, and then you are taking home what minus 12 here, right? So this is how simple you have to solve almost all the graph questions under quadratic. You need to have these two guys. So let's see how to copy and complete the table here. So with the table, this is what you are having. So you are having let's say the first person brought out minus 5 here, and then that person takes somewhat minus 12. So when you came with minus 4, you are going with what minus 5. If yours is what minus 3, you are going with a 0. So this is how simple you have to copy and complete the table here by doing that calculation. Okay, now from the question, the next thing that we are having that is we should solve some of the questions that follows, right? They say using a scale of 2 centimeters to 1 unit on the x-axis and 2 centimeters to 2 units on the y-axis. Draw on the same graph sheet the graph of the relation. So you are having the relation. So we are going to draw this thing here, right, as well as this guy here. So let's see how to draw that. So I have a very beautiful graph here. Maybe your graph sheet might be different from mine, but what matters here is the understanding. Okay, now they say 2 centimeters to 2 units on what the x-axis. What it means is that, look at something from here to here is 2 centimeters, right? From here, this side to this side is 2 centimeters. So from here to this side we go just 1 centimeter. That is 1 unit here, right? So 2 centimeters to 1 unit, meaning that from here to here, that is 2 centimeters. So you should name here 1, right? So from here to here, you should name there 2 on the x-axis. So this is exactly this line here. The one goes this way, left to right or right to left is what the x-axis. So let's name here this here x, and then this one will be what our y-axis, right? What matters here is that you have to make sure that all the numbers are available. So the smallest among the x is what, minus 5, and the largest among them is what, is 3, right? So let's see how to name that. So here I divided my graph into 2 because I want to have all the values of the s on the graph sheet, as well as the values of the y on the same graph sheet. So here is the 0, the starting point. So it's a 2 centimeters to 1 unit on the x-axis. So this is the x-axis here, right? So here to here will be what, 1, and then from here to here is what, to be what, 2 here, and then from here to here will be 3, and so on and so forth. So on the left hand side of the 0 is what, minus. So negative 1 here, negative 2, negative 3, negative 4, negative 5, right? So you just need to check whether all the numbers are available. Of course, that you have a minus 5 here, as well as a positive 3 available. So the same thing on the y. They say that from the y-axis, they say 2 centimeters to 2 units on the y-axis, meaning that every 2 centimeters that we are having, look at something. So the y-axis is the one that goes from top to down, right? Or maybe down to top. Okay, so starting from the 0, I have 2 centimeters is here. I will see 2 centimeters from here to here is 2 centimeters. This should name this part 2 units, meaning here is to be 2, and then here should be 4, 6, and so on and so forth. So down the 0 is what, the minus here. So here should be minus 2, minus 4, minus 6, minus 8, and so on and so forth, right? Okay, now let's see how to plot the point. For you to plot the point, you have to move in pairs, right? You have to move in pairs. So what your amount as well as the product that you are taking home. So from the first part here, you can see that here you are having what, minus 5 comma minus 12, or maybe negative 5 comma negative 12. So now let's look at the negative 5 comma negative 12 here. So negative 5 on the x-axis, meaning that you came with negative 5. So here's the negative 5 here. And then what are you taking home? You are taking home what, negative 12 here after the calculation, right? You just need to stand here. This is what, the negative 5 on the x-axis. Remember that here you work in pairs, right? Your amount, the amount that you brought, and the product that you are taking home. So you came with minus 5, then you are taking home what, negative 5, negative 12 here, sorry. So here should be a negative. This is exactly where you are on the graph sheet. So the next one is minus 4, negative 4 comma negative 5. So this is what you came with, negative 4, and then you are going home with a negative 5 after doing the calculation. Look at something. Here is 4, here is 6, right? So automatically here should be what, 5 here. So negative 5 here on this line, right? So here should be what, a negative 5 here. So the same way you need to plot all the points here. If you plot all the points, you should have something that looks similar to mine. So from here, this is the first point, so this is the second one, and then fourth, fifth, and so on and so forth, right? Okay, so just plot them. When you are done, you just use a freehand sketch here to join all the points together. So from here to this side, right? From here to this side here, is that okay? And then from here you join all the points, right? You join them with what, a freehand here. Okay, this is a beautiful graph that I'm having here to the relation y equal to 3 minus 2x minus x squared, right? So this is how simple you have to draw a quadratic graph under this circumstance. Now look at the second one. They say you should draw on the same graph sheet two relation, right? So meaning that you have a different slope with what, they are law, right? So this is how it looks like. That is what, y plus 2x plus 4 equal to 0. Remember what I said earlier on, that you need to go with something before you get your product out, right? You must have certain amount of money before you take your product out. So look at this one. You need to rewrite this expression or this equation here to look like what am I taking home if you are going with like just a certain amount of money here. So after rewriting this thing, this should look like y equal to minus, you are just taking everything to the other side to look like something of this nature. The reason is that you must go with something that before you take your product home, right? But these two guys are being combined into one place. We don't want that. We don't want that. So you have to make sure that this guy is standing alone. So when you go with certain amount of money, you are taking home another product. And that is why I send this guy to the other side, this guy also to the other. So have something like y equal to minus 2x minus 4 here. right? Okay, now how do you draw this line here, this graph here? Remember I said earlier on that you need two things. You must go with something and then you get your product home, right? So in this case, if you are not giving any point for, you can just pick any point, right? From what we are having here, you have some values of the x here. So yeah, what I need is that we need a 2 point to draw this two graph here. So what that matters here is that maybe if I go with what -4 here, what am I taking home using this law here? This, assume this is the second store, right? So maybe you went there with what -4. This -4 can be any number of your own choice, so maybe you can pick it from what the questions being given to you, right? So okay, now we just need two of them to draw the line. Right. Okay, so when you go with your -4, meaning that when x is equal to -4, what are you taking home? You are taking home, we are just replacing the x here by what -4, right? So that gives me y equal to -2 into bracket -4 here. So that should be 8 -4, that is equal to 4. So when you go with -4, you are taking home what 4 here. Okay, so meaning that the point here, that point should be what -4, 4, right? So meaning you go with -4 and then you are taking home what 4. So you go to your graph sheet and plot that point, right? Remember it is two relations that we are drawing here. So -4, 4 to be this is what my -4 here. So let's look at 4. Where exactly is 4? So you are taking home 4. So you need to go up, right? You need to go up on this line here. So I have what at this point. So the second one, we need 2 points. Is that okay? We need 2 points to draw, or maybe more than 2 points. Okay, so the next one is that when s is equal to if someone also goes with 3 here, then that person is taking home what -10. After plugging the 3 into that relation, which is equal to y equal to -2, 3 -4 here. Okay, that should be -6 -4. That should give me -2. So if you go with 3 here, then you are taking home what -10, right? Okay, so we go with 3. So let's locate the 3 on the x-axis here. So 3 is here, and then we are taking home what -10. So you need to go down, right? Be on the line, that straight line. So -10 is somewhere on this line here. Okay, so here should be what -10. Now the reason why we need just a 2 points here, or more than 2 points here, so that this is 1 point for the relation that we are drawing, and then this is the second one. The second one is here. So join them, right? Join them with a rule to have a straight line. So after joining the 2 points, you should have a straight line, right? This is a straight line. Okay, maybe one trick here is that mathematically, if you have any relation that does not contain maybe raised to the power 2, 3 or something like that, that is just a straight line, right? And then if you have another one that is the highest power of this value here is 2. What I mean by that, the x is s squared, then you are going to have a quadratic, right? Something like a curve, but this one should be just a straight line. Okay, now from this is what we are having. They say you should find the equations of what a symmetry, right? The equations of the symmetry. You should just know who exactly what we call a symmetry. When you say equations of a symmetry, it's exactly where this curve here, you see this curve here is being divided into 2, right? Being divided into 2. What I mean being divided into 2, look at this one. This one is what maybe upside down, something of that nature. So exactly where the line where we can divide this thing into 2 equal parts. Obviously from here to here is one part, and then from here to this side is also another part. So where the half, let's say half of the graph here is the line of a symmetry, right? This is exactly the line of a symmetry that we are talking about. Okay, so what is the number here? So that is the equation. Is that okay? What is the number here? The line of a symmetry of a quadratic is exactly, we are dividing the graph into 2 equal parts, right? So this is what the turning point, or the 2 equal parts of this graph here. So which number is here? This is what -1. So the equations of a symmetry is this, what s is equal to -1. The x here, because on this axis is exactly s, so this line belongs to the x, right? So the equations of a symmetry is what exactly s is equal to -4. So that is exactly what I'm having at this point here, right? So the equations of a symmetry is what s is equal to -5. The next one says that if you find the solution set of a certain equation, right? But what you know is that, remember the question say from the graph, right? They say from the graph, so we are going to use the graph to solve everything that we are doing here. Okay, now we don't have anything from the graph. That is, maybe we are giving x square minus 7 equal to 0. This is what we are giving, right? We don't have anything from the graph that looks like that. So what are we having here? We are having this guy here, which is the first store here, and then this is the second one, which is the second store. What do? With these two things we can find this guy. Is that okay? So let's equate the two and see whether we arrive at something that looks like this. If you get something like this, then we are guaranteed that we can use our graph to solve this type of problem. So let's equate the two, right? We are equating the two. So how do you do that? So we have this guy equal to this guy. So that is exactly what I have here. That's the 3 minus 2x minus s squared is equal to minus 2s minus 4. The reason that we want to check whether we can have this guy out of the two equations here. Okay, so after solving this thing, so luckily or fortunate for us, we are having what 7 minus s squared, right? 7 minus s squared here. So if you rearrange, send everything to the right hand side, you should arrive at x squared minus 7 is equal to 0, which is exactly what we are looking for. We have been given from the question. So here we can guarantee that we can use the graph to solve this type of problem here. So this is the solution set. It means that if you equate this guy to that guy, so meaning that they are equal, right? So after equating this one to mean that they are equal, they are the same. If they are the same, then they have the same value. Is that okay? So what I mean by they have the same value is that maybe at that point the price of the first store is the same as the price of the second store. Is that okay? Okay, so from the graph, this is exactly where the two guys meet. So the first store and the second store. So look at this one. So this is the first store, or maybe this is the first store here. The curve here is the first store, and then this straight line is the second store. So where they meet, right? They meet at this point. This is 1. So meaning that they are having the same price here. Remember, the price here is the x what we are taking along. So whatever is here is the first price here, and then here they also meet at this point here, right? They also meet at this point here. So here too you need to go up. Is that okay? Here too you need to go up on this line here, right? You need to go up on this line here to locate what our x, meaning what we are or the amount of money that we are having. Is that okay? So this will be what one amount of money, and this will be the second amount of money that we are having, since the two lines intersect. Right? What I mean by the intersect is that after equating the two, we had our s squared minus 7 equal to 0. So at this point here, they have the same price of a certain product here, right? So you just need to read this one here. Here should be 1.1. So after reading, here should be so that should be 2.6, right? So how to read this thing here is very easy. So from here to the biggest interval is 1. So from here to here is 1. From here to here is 1. So 1 divided by the subdivision. So the subdivisions here are 10, right? So 1 over that should give you, let's say 1 over 10. That should go 0.1, right? So meaning that each smaller box here is also 0.1, right? 0.1. So here should be 5, 0.6. So the first one should be what they say the true set. So remember how to write that true set. That is x such that s is equal to minus 2.6 here, and then you need to read the second one have the same values of that. So that should be what 2.8, right? Can you see that from here to here? That should be 2.8. So that's the true set that they are asking us to find from this type of problem here. Now the next one says you should find the values of s for which the relation, so meaning that this is the relation that we are having. Of course, this is what we have graphed so far, right? That is the y equal to 3 minus 2s minus s squared. And they say you should find the values of s for which this one is greater than 0. We are still using the graph. Is that okay? Just go to your graph and go and read which value you want, the values of the y that are greater than 0. That is why you need to know exactly where the y is. So this line is what is for the y. So look at the graph. This is the graph that we are having. So anything that is below this line are negative. Can you see that? Here look at something. We are starting from here. This is the 0 point, so anything down the 0, you have to be on the y line, right? So the y axis is, so anything below this line are what, are negative, so we don't want that, so we can go up. Is that okay? So maybe this is the portion that we are talking about, right? So up from here to here. So look at something. So from here is what, a -3, and then to what, +1. Have you see? So from -3 to +1, these people are more than 0. Meaning that you are taking something home. So the values of the y are what, more than 0. That is exactly what they are asking us to find. So the value of x, right? So maybe the price that you must take along before you should have something that is bigger than 0 are what? If you go with what, -3, you get something that is what, bigger than 0, right? And then and so on, -3, -2, -1, 0, up to what, up to 1. Of course, you get something that's what, greater than 0. You can see from the graph. If you don't know, you come down this way, you are going to get negative. You don't want that. The question says that you should find the values of the y that the relation is greater than 0. So from -3 to +1 is exactly what we are looking for. So this is how you should write that. So meaning that x is greater than what, -3, s is less than what, 1 here. So this is how simple you solve one of the quadratic graph in examination. Thank you for watching this. Give us a thumbs up if you enjoyed the video, and subscribe to the YouTube channel for more content like this. Sure.